Next topic which you need to cover is the Diels-Alder reaction. This is the first reaction which is named after the chemist instead of chemistry. What actually happens in this reaction, where a conjugated diene reacts with a double bonded dienophile. And what is the Huckel's rule? And what are the common facts about the Diels-Alder reaction? Like the dienophile can be considered as simultaneously a nucleophile and electrophile. Then the driving force in the conversion of two pi bonds into two sigma bonds, and the reaction will not happen without a Huckel number of electrons. What are the properties of dienes and dienophiles? Dienes electron rich and dienophiles electron poor. Go through the example for it. For the other properties of dienophiles, typical dienophiles have electron poor double bonds. So how on this basis a poor dienophile and a good dienophile can be defined? Then what is the homo-LUMO interaction? They can work in either of the direction. Then what is the regiochemistry of Diels-Alder reaction? You also need to examine the resonance contributors of the diene and dienophile. The preferred regiochemistry matches positively and negatively charged ends. Then what should be the conformation of diene for the reaction to occur? What is conformational locking and how is it helpful in the reactivity? And how it can change the reactivity? And we also know that the Diels-Alder reaction is stereospecific in the dienophile and also in the diene, and this kind of reaction can form asymmetric carbon atoms. Whatever points I have just mentioned, for example, the stereochemistry in cycloaddition of 1-methoxybutadiene and cyanoethylene. After covering this, you need to cover other important reactions of organic chemistry like the Witting reaction. So for this you need to know what is actually this reaction and what are the reactants and the end product. Then what is the mechanism of Witting reaction? What are the steps, different steps involved in that? Then what is the stereoselectivity of Witting reaction? What is the Z-selective Witting reaction? Then what is the E-selective Witting reaction with examples? Another important reaction type related to organic compounds is the hydroboration. What is actually hydroboration? It refers to the addition of a hydrogen boron bond to carbon-carbon or carbon-nitrogen and carbon-oxygen double bonds, as well as carbon-carbon triple bonds. This reaction is useful in the organic synthesis of organic compounds. So go through the reaction mechanism and also go through different examples like the reactions involving substituted alkenes, then the reactions of organoboranes, that is the hydroboration oxidation reaction. Then what are the different borane sources? And then what are monosubstituted boranes, disubstituted boranes, dicyl borane, 9-BBN. It belongs to the dialkyl boranes. Then what are other secondary boranes? So you should be well aware of all these examples of boranes. Then finally you have to go through the chemical tests for the identification of different functional groups. So let's start with the amides. So what So what will be the product when the reaction of amides are done with the sodium hydroxide? The gas can be tested by a moist red litmus paper, which is then turned blue, that is ammonia. Then the alkaline hydrolysis of aromatic amides, which will form the aromatic acid. Then there is biurate reaction for aliphatic diamide. Then hydroxamic acid test for aromatic primary amides. So these were the few tests for amides. So you go through all these and you should know what are the products formed in each case, which will confirm the presence of amide in the compound. Then what are the reactions for carboxylic acids? First one is the reaction with sodium hydroxide. Then what will be the product? It gets dissolved in it and it forms sodium salt. Then what is the reaction with the sodium bicarbonate? Carbon dioxide is formed. Then the reaction with the fluorescein. Then the formation of anhydride when heated at its melting point. For example, the aromatic 1,2-dicarboxylic acid. These were the tests for carboxylic acid. Now the test for phenols. The reaction with neutral ferric chloride solution, which forms the characteristic colored iron complexes when treated with neutral ferric chloride solution. In the formation of azodyes, aryl diazonium salts react with aromatic rings of phenols to form highly colored azo compounds. Then the reaction of benzylation. Then after this, what are the reactions for primary amines? That is the diazotization. Then the azodie formation for aromatic primary amines. These are the reactions called coupling reactions. Then the benzylation. What are the products formed in that? Then Hinsberg reaction. What are the products formed in that for primary amines? Then what are the tests for aldehydes? What is the action of Schiff's reagent on aldehyde? Then the action of Bosch reagent. Then another test is the action of Tollens reagent. What are the products formed by the action of sodium bisulfite solution? So you should go all through these tests and what are the products formed in each case. Then what are the confirmatory tests for the Bosch reagent for the ketones? One is the action of Bosch reagent, then the other one is the action of sodium nitroprusside solution, which forms a colored complex with methyl ketones. So you should go all of these. Then what is the general approach in determining a functional group of an organic compound? So first you should go for the action of sodium hydroxide solution. By that you can determine whether the compound contains amides or acidic substances or aromatic or is it aromatic amide. Then the next step could be the action of sodium bicarbonate. It could tell whether the acids are present in the compound or not. The next could be the action with ferric chloride solution. It could detect the presence of phenols in the compound. Then the next is the action of Schiff's reagent. It could tell the presence of aldehydes. Then the action of Bosch reagent. It could tell the presence of aldehydes or ketones. Then you can go for the diazotization, which will tell the presence of primary aliphatic amines. Then for the test for the presence of aldehydes, you can go for the action of Tollens reagent, or the action of sodium bisulfite solution, which will confirm the presence of aldehyde. Then for the ketones, you can go for nitroprusside test. Then for the acids, you can go for the fluorescein reaction or the anhydride formation. It can tell about the presence of dicarboxylic acids. For amides, you can go for the biurate reaction or the hydroxamic acid test. Then what are the confirmatory tests for the presence of aromatic amines? Primary. It could be benzolization or the addition of cold diazonium solution. Further, you can go for the test of aliphatic amines, primary. Then what are the tests for the aromatic alcohol phenols, azodie formation and the benzolation? So these were the confirmatory tests for different functional groups. So by following this protocol, you can predict the functional groups of the organic compound. These are very important. You need to go through all these. What are the reactants? What is the end product? What is the confirmatory test for a particular functional group? All these points you need to cover. So this was all about the structure reactivity correlations and organic reaction mechanisms. You can prepare this portion in 3 to 4 days. It is very important for this section to clear all your basics about the different concepts like isomerism and different reaction mechanisms. I hope you find this information helpful, and I wish you good luck for the exam. Thank you.